Hi and welcome to Apex Atlas. Stretching from the Caribbean Sea in the north to the sprawling rainforests of the Amazon basin in the south, Venezuela is one of the most ecologically diverse nations on Earth. Venezuela is recognized as one of the world's megadiverse countries, home to an astonishing array of ecosystems, from the snow-capped peaks of the Andes to the broad floodplains of the Llanos, from ancient tabletop mountains surrounded by mist-shrouded forests to coastal islands fringed by coral reefs. Here, rivers run wide, forests breathe deeply, and landscapes carved by water, wind, and tectonics hold life found nowhere else on the planet. This is a land of extremes and transitions, where nature refuses to be compartmentalized, and where every region tells its own story of survival, adaptation, and connection. In this documentary, we will explore Venezuela's natural heart, its mountains, plains, rivers, forests, and seas, and the living threads that bind them together. This is nature on a grand scale, ancient, richly layered, and constantly evolving. Mountains of ice, plains of grass, forests ancient and deep. Venezuela's landscape is a tapestry woven from multiple geographic threads, each one as dramatic and vital as the next. In the west rise the Andes Mountains, a continuation of South America's Great Spine. Here, peaks like Pico Bolivar soar toward the sky, their snow-tipped summits catching light at dawn and feeding glacial streams that sustain ecosystems far below. To the east of these soaring heights lie the Llanos, vast, grassy plains stretching toward the horizon, where seasonal rains transform quiet grasslands into flooded wetlands alive with fish, herons, capybaras, and giant antitas. The Llanos are a land of rhythm and pulse, where water and drought alternate over the year, shaping the lives of animals and humans alike. Farther south, the land deepens into the great Amazon rainforest, a sprawling network of forest canopies and winding rivers that forms one of the richest ecological mosaics on Earth. This region is part of the Guiana Shield, a geological formation older than the Andes themselves, whose rivers, valleys, and hills support ancient forests, filled with orchids, jaguars, tapirs, and dazzling birdlife. Running through the heart of Venezuela is the mighty Orinoco River, one of South America's great arteries of water, stretching for more than 2,100 kilometers before spilling into the Atlantic. Its vast basin creates wetlands, channels, and deltas that nourish an extraordinary variety of life, from river dolphins and caimans to iridescent kingfishers and herds of deer. The Orinoco Delta is not just water on land. It is a landscape of life, where seasonal floods shape forests, grasslands, and channels in perpetual motion. But Venezuela's topography is not simply mountains and rivers. In the southeast, the Guiana highlands rise as ancient plateaus known as tepas, towering mesas whose flat summits host unique species found nowhere else. These mystical table-topped mountains, like Roraima, are often shrouded in mist, their sheer cliffs dropping into forests that have remained unchanged for millennia. Surrounding all these are Caribbean coastlines, islands, reefs, and coastal plains that stretch out toward open ocean, while inland valleys and dry forests create further variation in climate and life. Taken together, these dramatic landscapes define a country where climate and geology produce patterns of life more varied than in most places on Earth. From alpine cold to tropical heat, from flooded wetlands to windswept highlands, from pristine rainforest to sprawling Llanos grassland. In Venezuela, every terrain has its own story, and every ecosystem adds another thread to a natural tapestry unlike any other. Climate and seasons across a land of extremes. In Venezuela, climate is not defined by 4 seasons, but by altitude, latitude, and water. Straddling the equator's northern edge, Venezuela sits firmly within the tropics. Temperatures in lowland regions remain warm throughout the year, often fluctuating more between day and night than between months. Yet to describe the country as simply tropical would be misleading. Venezuela's true climatic diversity lies not in latitude, but in elevation and seasonal rainfall. Along the Caribbean coast, the climate is hot and humid, moderated by sea breezes and shifting trade winds. Here, rainfall patterns vary by region. Some coastal areas remain relatively dry for much of the year, supporting thorn scrub and dry forest. Others, especially along the eastern coast and near the Orinoco Delta, receive heavier rains that sustain lush vegetation. Move inland toward the Orinoco River, and climate becomes defined by rhythm rather than temperature. The Llanos experience 2 dominant seasons, wet and dry. From roughly May to October, monsoon rains transform the plains into vast wetlands. Rivers overflow, grasslands flood, and fish disperse across temporary inland seas. Capybaras graze at the water's edge. Caimans patrol newly formed channels. Wading birds gather in astonishing numbers. Life expands with the rising water. Then, as the dry season returns, the transformation reverses. Floodwaters retreat. Grasslands re-emerge. Wildlife concentrates around shrinking pools and permanent riverbanks. Predators gain advantage. Survival becomes more difficult. This dramatic oscillation shapes one of the most dynamic seasonal ecosystems in South America. Further south, the Amazonian regions of Venezuela experience high rainfall throughout most of the year. The canopy remains green and humid, with only subtle fluctuations in precipitation. Rivers swell and contract, but forest structure remains dense and continuous. Here, climate supports one of the richest biodiversity reservoirs on Earth. Yet the greatest climatic contrast lies in the mountains. In the Venezuelan Andes, elevation creates entirely different environmental zones. At lower slopes, cloud forests thrive in constant mist, fed by moisture rising from lowlands. As altitude increases, temperatures drop steadily. High Paramo ecosystems emerge above the treeline, windswept, open landscapes where frost can occur at night despite tropical latitude. At the highest peaks, snow still falls in winter months, though glaciers have dramatically receded in recent decades. These frozen remnants once fed downstream rivers year-round. Now, climate warming threatens their disappearance entirely. In the southeast, the Tepuy Plateaus of the Guiana Highlands create microclimates of their own. Their isolated summits receive frequent rainfall and mist, supporting plant species found nowhere else. Sharp cliffs trap clouds, creating self-contained ecological islands suspended above surrounding forest. Across Venezuela, climate is layered, vertically and seasonally. From alpine cold to equatorial heat. From drought-stricken plains to rain-soaked forest. From tidal delta to mountain mist. These climatic gradients allow ecosystems to stack tightly together within a single national boundary. Wildlife migrates vertically. Rivers link seasons. Forests buffer extremes. But this complexity also means vulnerability. Changes in rainfall patterns affect the llanos immediately. Temperature rise threatens high-altitude species with nowhere higher to retreat. River systems depend on predictable seasonal flow. In Venezuela, climate is not background. It is the invisible force shaping mountains, feeding rivers, flooding plains, and sustaining forest. And in a country of such vast natural variation, even small shifts ripple across entire lands. Capes. The Andes and Paramo, life at the roof of the tropics. In western Venezuela, the land rises abruptly. The Andes, South America's great mountain chain, enter Venezuela from Colombia and climb towards some of the highest elevations in the northern tropics. Peaks such as Pico Bolivar pierce the sky above 4,900 meters, standing as the highest point in the country and once crowned by glacier that fed rivers year-round. Here, altitude reshapes everything. At lower elevations, humid Andean foothills are cloaked in cloud forest. Moist air rising from the llanos condenses against steep slopes, feeding dense vegetation where moss blankets tree trunks and orchids cling to branches. These forests are dim, dripping, and alive with sound. Hummingbirds flash between flowers, while spectacled bears and mountain tapirs move quietly through understory. Climb higher, and the forest thins. Above the tree line begins the Paramo, one of the most distinctive high-altitude ecosystems in the world. Despite lying within the tropics, the Paramo experiences freezing night temperatures, intense ultraviolet radiation, and strong winds. Days may be warm under bright sun, yet frost can form before dawn. Plants here are specialists. The most iconic is the frailgen, tall, woolly-leaved plants that resemble sentinels guarding the slopes. Their thick leaves trap moisture and insulate against cold, while their stems store water like natural reservoirs. Entire hillsides shimmer silver under morning light. These highlands are not barren. They are living water towers. Rain and mist captured by Paramo vegetation feed streams that merge into rivers flowing toward the Llanos and Orinoco Basin. Without these upland ecosystems, seasonal water regulation across much of Venezuela would falter. Wildlife adapts in subtle ways. Andean condors ride thermal currents above ridgelines. Small rodents burrow beneath grass tussocks. Amphibians and insects survive in isolated alpine wetlands, some species found nowhere else on Earth. Isolation plays a role here too. Mountain peaks function like islands in the sky. Species separated by valleys evolve independently, creating pockets of endemism unique to individual ranges. But the Andes are also fragile. glacier that once crowned Venezuela's highest summits have almost entirely vanished in recent decades, victims of global temperature rise. With them goes a stable source of meltwater that historically sustained downstream ecosystems through dry months. Climate warming is pushing species upward, yet mountains have limits. Beyond the summit, there is nowhere left to go. The Venezuelan Andes represent an ecological paradox. A cold world within the tropics. A high-altitude refuge surrounded by lowland heat. They regulate water, store carbon, harbor rare species, and they remind us that Venezuela's diversity is not only horizontal, across plains and forests, but vertical, stacked from sea level to a alpine sky. The Llanos, flooded plains of abundance. East of the Andes, the land opens, stretching across central Venezuela. The Llanos form one of the largest tropical grassland systems on Earth, a vast, seemingly endless plain shaped not by mountains or forests, but by water. For much of the year, the Llanos appear dry and golden. Grasses sway under intense sun. Scattered trees dot the horizon. Rivers cut broad, winding channels through flat terrain. It can seem quiet, almost empty. But this stillness is temporary. When the rainy season begins, everything changes. Monsoon rains sweep in from the south and east, swelling tributaries of the Orinoco River. Water spills across the plains, flooding thousands of square kilometers. Grasslands become shallow lakes. Forest islands rise like archipelagos from a seasonal inland sea. The transformation is explosive. Fish disperse into newly flooded areas to feed and spawn. Capybaras gather along water's edge in large herds. Anacondas glide silently through submerged grass. Caimans bask on exposed banks, waiting for opportunity. Birdlife reaches extraordinary densities. Scarlet ibises, herons, storks, and egrets converge in staggering numbers. Raptors circle overhead. Jabiru storks stalk fish in receding pools as the waters begin to fall. The Llanos are not just grasslands, they are a seasonal pulse. The flood nourishes soil. The retreat concentrates life. Predators and prey adapt to a landscape that alternates between abundance and scarcity. During the dry season, water evaporates rapidly under tropical sun. Wetlands shrink into isolated ponds. Wildlife clusters around remaining water sources, intensifying competition. This concentration makes the Llanos one of the best places in South America to observe large animals in the wild. Yet beneath this dramatic cycle lies delicate balance. The Llanos depend entirely on predictable rainfall patterns and upstream river flow. Disruptions, whether from climate variability, deforestation in the Andes, or altered river systems, can ripple outward across the plains. Unlike forests, grasslands reveal change quickly. Drought lingers in cracked earth. Flood shifts reshape channels. Fire can sweep rapidly across dry vegetation. But the Llanos are resilient. Grasses regrow. Rivers carve new paths. Life adapts to rhythm rather than permanence. In contrast to the dense Amazon or towering Andes, the Llanos offer openness, a horizon unbroken by canopy or cliff. Yet their ecological importance rivals any rainforest. They are a breeding ground, a living floodplain tied intimately to the Orinoco Basin. In Venezuela, the llanos represent motion in slow cycles, a landscape defined not by static form, but by water, rising and falling. The Amazon and Guiana Shield, forest older than mountains. South of the llanos, the landscape changes once again. Here, in southern Venezuela, lies one of the most ancient geological regions on Earth, the Guiana Shield. Long before the Andes rose, before the Amazon River carved its present course, this shield of Precambrian rock stood exposed. Its foundations are billions of years old, older than most mountain ranges, older than the Atlantic Ocean. Upon this ancient bedrock grows one of the planet's richest forests. Venezuela's Amazon region forms the northern edge of the greater Amazon basin, a vast, interconnected system of rainforest, rivers, and wetlands that stretches across multiple countries. Here, the forest is dense, humid, and layered. The canopy rises high above the ground, forming a living roof that filters sunlight into shifting green light below. Massive trees anchor themselves in shallow but stable soils, their buttress roots spreading wide for support. Beneath them, layers of vegetation create vertical complexity, lianas climbing toward light, epiphytes clinging to branches, ferns thriving in dim understory. This forest is not uniform. Blackwater rivers snake through dark-stained channels, their acidity shaping specialized plant and fish communities. Whitewater tributaries carry sediment from the Andes, enriching floodplains where trees are adapted to months of seasonal inundation. The Orinoco River plays a defining role here. Unlike the Amazon proper, the Orinoco flows north and east, creating its own immense basin. During high water, floodplain forests become submerged for weeks at a time. Fish feed among tree trunks. River dolphins navigate flooded woodland corridors. Wildlife thrives in this complexity. Jaguars move silently along riverbanks. Tapirs browse beneath fruiting trees. Harpy eagles hunt from towering canopy perches. Thousands of insect species pollinate, decompose, and sustain food webs largely invisible to the eye. The tepees, towering flat-topped mountains rising abruptly from the forest, add another dimension. Formed from ancient sandstone, these mesas are ecological islands suspended above surrounding rainforest. Their vertical cliffs isolate summits for millions of years, allowing evolution to proceed independently. Unique plants grow in nutrient-poor soils atop these plateaus. Carnivorous species trap insects to supplement limited minerals. Amphibians found nowhere else cling to mossy rock faces perpetually wrapped in mist. The Amazonian region of Venezuela is not merely biodiverse, it is structurally complex, hydrologically dynamic, and evolutionarily ancient. It stores carbon in massive quantities, regulates regional rainfall, and connects South America's ecosystems through waterways and forest corridors. Yet this forest is not immune to pressure. Illegal mining, deforestation, and climate shifts threaten delicate systems built over geological timescales. The Guiana Shield reminds us that Venezuela's biodiversity is rooted in deep time, in rock older than continents as we know them, supporting life that evolved slowly and intricately. Here, forest and stone meet, and in their union lies one of the oldest living landscapes on RTH. Tepes and lost worlds above the clouds, rising abruptly from the forests of southern Venezuela. The tepes defy expectation. These immense table-topped mountains, some towering over 2,500 meters above sea level, are among the most dramatic geological formations on Earth. Their sheer sandstone cliffs plunge vertically into rainforest below, isolating their flat summits like islands suspended in the sky. They are remnants of an ancient plateau that once covered much of the Guiana highlands. Over hundreds of millions of years, erosion carved away the surrounding rock, leaving behind these solitary mesas. Among them stands Auyan Tepui, from whose edge plunges the world's highest uninterrupted waterfall, Angel Falls. But it is not the height alone that makes the Tepus extraordinary. It is isolation. For millions of years, their summits have remained cut off from surrounding ecosystems. Steep cliffs prevent most animals from climbing. Wind and rain sculpt harsh conditions atop nutrient-poor sandstone soils. Mist frequently blankets the plateau, creating a cool, damp microclimate distinct from the humid forest below. Life here evolved independently. On the summits grow carnivorous plants that trap insects to compensate for mineral-poor soil. Tiny amphibians adapted to constant moisture inhabit shallow rock pools. Many species found on one tepui occur nowhere else, not even on neighboring plateaus. These summits function like biological laboratories of evolution. Each plateau is its own experiment. Some are home to dwarf forests shaped by wind. Others support open shrublands, bogs, and wetlands fed by constant rainfall. Rainwater pools atop impermeable sandstone, forming shallow lakes that reflect sky and cloud. The tepus also shape the land below. Their cliffs funnel rainfall into waterfalls and rivers that feed Amazonian tributaries. Seasonal storms cascade over their edges in silver curtains, replenishing streams and sustaining forest ecosystems at their base. Culturally and geologically, they inspire awe. Their dramatic silhouettes influenced legends long before modern science studied them. Their summits were once thought unreachable. Even today, access is limited and carefully managed. But fragility lies beneath the grandeur. Because tepui ecosystems are so isolated, they are also vulnerable. Climate shifts may alter mist frequency and rainfall patterns. Species with narrow habitat ranges have nowhere else to migrate. The tepus represent time made visible. Stone sculpted by erosion. Life shaped by isolation. Worlds perched between earth and sky. In Venezuela, nature does not simply vary across landscapes. It rises vertically into realms so unique they seem almost separate from the planet below. And on these ancient mesas, we glimpse evolution unfolding in solitude. Rivers, deltas, and the Orinoco's living arteries. If mountains define Venezuela's height, and forests its depth, then rivers define its movement. At the heart of Venezuela flows the immense Orinoco River, one of the great waterways of the continent and the ecological spine of the nation. Stretching more than 2,000 kilometers in a vast arc across the country, the Orinoco does not simply drain land. It shapes it. Born in the remote highlands near the Brazilian border, the river gathers tributaries from the Andes, the Llanos, and the Guiana Shield. Each region contributes something different: sediment from mountain slopes, nutrient-rich runoff from floodplains, tannin-dark waters from rainforest streams. As the Orinoco widens, it becomes less a single channel and more a shifting system of braided waterways. During the rainy season, it spills far beyond its banks, submerging forests and grasslands alike. Floodplain forests adapt to months underwater. Trees grow tall, with trunks capable of surviving seasonal inundation. Fish migrate into submerged woodland to feed on fruit and seeds. River dolphins navigate between tree trunks where land and water temporarily merge. In the llanos, tributaries of the Orinoco pulse with seasonal life. Floodwaters nourish wetlands that become breeding grounds for fish and feeding grounds for birds. As waters retreat, nutrients remain, sustaining productivity long after the flood has passed. Toward the Atlantic, the river transforms again. The Orinoco Delta is not a single mouth, but a labyrinth, a fan of channels spreading into mangrove-lined waterways and tidal wetlands. Here, fresh water meets ocean in a slow blending of currents. Mangrove forests anchor the delta's shifting sediments. Mudflats host migratory birds traveling between hemispheres. Estuarine waters support fish nurseries critical to coastal ecosystems. The river also connects continents in unexpected ways. Through the Cassiquiare Canal, a natural distributary, the Orinoco links with the Amazon basin, forming one of the rare hydrological connections between two major river systems. This network of waterways creates corridors for wildlife movement and genetic exchange across immense distances. But the Orinoco's scale does not shield it from pressure. Mining in upstream regions introduces sediment and pollutants. Deforestation alters runoff patterns. Climate variability changes flood timing and intensity. Because rivers integrate entire landscapes, they reflect every change made upstream. Yet the Orinoco remains one of South America's least fragmented major rivers. The Orinoco is not merely a geographic feature. It is Venezuela's circulatory system, transporting nutrients, shaping habitats, connecting ecosystems. From mist-covered tepes to tidal mangroves, water binds Venezuela's vast diversity into one living network. Coasts, Caribbean waters, and marine life. To the north, Venezuela meets the Caribbean Sea, and with it, an entirely different dimension of life. More than 2,800 kilometers of coastline stretch from the arid peninsulas of the west to the mangrove-rich delta in the east. This boundary between land and sea is not uniform. It shifts in character from rocky cliffs and sheltered bays to coral islands and sandy beaches shaped by currents and wind. Offshore lie island systems like Los Roques, coral keys encircled by brilliant turquoise lagoons. Here, reefs form natural breakwaters, protecting fragile sand islands from wave energy. Beneath the surface, coral structures host parrotfish, angelfish, rays, and reef sharks. Seagrass meadows spread across shallow seabeds, stabilizing sediment and storing carbon. Unlike the dynamic rivers of the interior, coastal ecosystems depend on clarity and balance. Clear water allows sunlight to penetrate, supporting photosynthetic coral symbionts. Stable temperatures and salinity maintain reef growth. Mangroves along the coast trap sediment before it can cloud delicate marine habitats. Sea turtles nest on Venezuelan beaches, returning annually to lay eggs in warm sand. Dolphins travel along the coast in pods, navigating nutrient-rich waters influenced by ocean currents and seasonal upwellings. In some regions, coastal upwelling brings cooler, nutrient-dense water to the surface. This process fuels plankton blooms that support fisheries and seabird populations. Pelicans, frigate birds, and terns patrol these waters, diving where fish gather. The Orinoco Delta adds another layer of complexity. Here, freshwater flows into the Atlantic, mixing with tidal currents to form estuarine ecosystems of immense productivity. Mangrove forests stretch along winding channels. Mudflats support migratory birds traveling between North and South America. Yet coastal ecosystems face mounting pressure. Overfishing reduces marine stocks. Pollution from inland waterways eventually reaches the sea. Coral bleaching events linked to rising ocean temperatures threaten reef resilience. Because the Caribbean is semi-enclosed, pollutants can accumulate rather than disperse rapidly. What enters the sea often remains within it. Still, marine protected areas provide refuge. Islands and reef systems under conservation show signs of recovery when fishing pressure declines. Coral resilience improves where water quality remains high. Venezuela's coastline is more than a scenic boundary. It is a transition zone, where freshwater meets salt, where continental ecosystems connect to open ocean, where terrestrial nutrients fuel marine life. From coral lagoons to mangrove deltas, the Caribbean edge of Venezuela adds another layer to an already complex natural mosaic. Mountains rise inland, rivers flow outward, and at the coast, all systems converge. Nature under pressure. For all its vastness and diversity, the natural systems of Venezuela are not immune to strain. In a country where ecosystems are tightly interlinked, mountains feeding rivers, rivers sustaining plains, plains connecting to forest and sea, pressure in one region rarely remains isolated. In the south, parts of the Amazon and Guiana Shield face increasing disturbance from mining. Gold extraction, often informal and poorly regulated, strips vegetation, diverts streams, and introduces sediment and pollutants into river systems. Mercury contamination can travel far downstream, affecting aquatic life within the Orinoco River basin. Where forest cover is removed, soils erode quickly under tropical rainfall. River clarity declines. Flood patterns shift. Because many Amazonian ecosystems evolved over geological timescales, recovery is slow and complex. In the Andes, climate change is reshaping high-altitude environments. Glaciers that once crowned Venezuela's highest peaks have almost entirely disappeared. Paramo ecosystems, finely tuned to narrow temperature ranges, are sensitive to warming trends. Species adapted to cool alpine conditions are being pushed upward, towards summits that offer no further refuge. Water systems downstream depend on predictable seasonal flow. As temperature and rainfall patterns change, so too does river timing. Flood pulses in the Llanos may arrive earlier, later, or with altered intensity, disrupting breeding cycles for fish and birds that evolved around stable rhythms. Across the Llanos, prolonged droughts in some years intensify wildfire risk. Grasslands that rely on seasonal inundation can suffer when rainfall patterns become irregular. Fire, once a natural but limited force, may burn hotter and spread faster under extended dry conditions. Along the Caribbean coast, oil infrastructure and maritime traffic introduce additional environmental risk. Spills, even when localized, can damage mangroves, coral reefs, and fisheries. Because marine ecosystems depend on clean, oxygen-rich water, contamination can have cascading effects. Urban expansion and infrastructure development also fragment habitats. Wildlife corridors that once allowed movement between ecosystems narrow or disappear. Large mammals require connected landscapes. When those links are broken, populations become isolated. Yet Venezuela's natural systems remain among the most intact in South America in certain regions, particularly in remote Amazonian and Tepuy landscapes. Large areas remain difficult to access, which has historically limited widespread industrialization. The question is not whether pressure exists, it clearly does. The question is how resilient these systems will prove under accelerating global change. Venezuela's diversity is its strength. Multiple ecosystems, varied climates, vast river networks, all create layers of redundancy and adaptability. But resilience depends on connectivity and balance. When rivers flow freely, forests regulate climate, and wetlands buffer extremes, nature absorbs shock. When fragmentation increases, vulnerability grows. Nature under pressure in Venezuela is not a sudden collapse. It is a gradual testing of systems built over millions of years. And in landscapes shaped by deep time, even modern disturbances can leave lasting marks. The future of Venezuela's wild landscapes. The future of Venezuela will be shaped by scale, connectivity, and choice. Few nations contain such a dramatic range of ecosystems within one border, from Andean summits to Amazon rainforest, from flooded plains to Caribbean reefs. This diversity offers resilience. When one system weakens, others can buffer and stabilize broader environmental processes. But resilience is not permanence. The survival of Venezuela's wild landscapes depends on maintaining the connections that bind them together. The Andes must continue to regulate water flowing toward the llanos. The Orinoco River must remain largely free-flowing to sustain wetlands and deltas. Amazonian forests must remain intact to regulate rainfall and carbon storage. Coastal mangroves must protect coral systems from sediment and storm surge. Protection efforts exist across much of the country. National parks such as Canema preserve vast stretches of Tepuy highlands and rainforest. Remote regions of the Guiana Shield remain sparsely populated, offering natural refuges for biodiversity. Yet the future requires more than isolation. It requires active stewardship. Reforestation in degraded areas can stabilize soils and restore wildlife corridors. Sustainable river management can maintain seasonal flood pulses. Marine conservation zones can help coral reefs recover from bleaching events. International cooperation is also critical. Venezuela's ecosystems are not confined by political borders. The Orinoco Basin connects to the Amazon. Migratory birds travel between continents. Ocean currents link Caribbean reefs to distant coastlines. Climate adaptation will define the coming decades. High-altitude species may need assisted conservation strategies. Floodplain management must anticipate altered rainfall patterns. Coastal planning must consider sea level rise and intensifying storms. But Venezuela's greatest advantage remains its ecological wealth. Large, relatively intact landscapes still exist. Wildlife populations persist in numbers rarely seen in more heavily developed regions. Ancient geological formations provide stability and structural complexity. If protected and connected, these systems can endure. The future of Venezuela's wild landscapes is not predetermined. It lies in the balance between extraction and preservation, between fragmentation and connectivity, between short-term gain and long-term resilience. Mountains still rise in the west. Rivers still pulse across the plains. Forests still stretch beyond the horizon. In a world where many ecosystems have already been heavily altered, Venezuela retains something increasingly rare: scale. And with scale comes opportunity. The opportunity to safeguard one of the most diverse natural mosaics on Earth for generations to come. A land of vast wild horizons. From the snow-dusted summits of the Andes to the flooded grasslands of the Llanos. From tepees rising through cloud to the winding channels of the Orinoco. Venezuela is a country shaped by scale. Here, nature does not exist in fragments. It flows. Mountains feed rivers. Rivers flood plains. Plains connect to forests. Forests breathe into the sky. This is a land where ancient rock supports living rainforest, where waterfalls plunge from prehistoric plateaus, and where wildlife still moves across landscapes vast enough to sustain it. But scale alone does not guarantee survival. The future of Venezuela's wild places will depend on connection between ecosystems, between protection and policy, between local stewardship and global awareness. Because in a world where natural systems are shrinking, vastness is rare, and rare things are worth protecting. If you've enjoyed this journey through one of South America's most extraordinary natural landscapes, please like the video. It truly helps support the channel. And subscribe to Apex Atlas for more cinematic documentaries exploring the nature, geography, and hidden ecosystems of countries around the globe. More landscapes, more wildlife, more stories written in stone, water, and forest. Thank you for watching, and we'll see you in the next destination.